how to use the meter. Saka unogona kokutesta, but you need to know what the meter is saying. Meter yako ikudii. Saka tikatesta pa meter panapa tinotesta iya tinoti continuity pamacomponents akawanda panapa. Kana tichitesta continuity, what we are saying is there an electrical connection between 2 points in a circuit? Iwewe unenge uchiziva the structure of, say, this house, unoziva kuti apa nepapa panofanira kuita electrical connection. Saka meter iyi unongoishandisa kuconfirm the existence of an electrical connection which is supposed to be there. So takatarisa meter iyi kafunction aka kane diode kane arrow which represents the diode ne ka item kanenge ka wifi yako ndo panotestwa chi continuity. So ndikabatanidza seizvi ndakaselekta ipapo meter yangu inoprodusa this audible sound yobva yaswitcha on light. Zvairi kundiudza iri ngoti between maprobes aya there is now an electrical connection between these two probes. Then ukatarisa ine value yairi kuindicata. This value indicated in the meter is the resistance between those 2 points. So we are testing two things all at once. Pane zvinhu zviviri zvekutestwa. Totesta resistance yemaprobes aya ne the existence of an electrical connection. You are confirming kakurira kakuconfirma that there is an electrical connection between these 2 points. So zvakudependa manje nokuziva kwako iwewe kuti what is the structure of a given component yauri kutesta. Then other than continuity or non-existence of the continuity, we also test resistance. Resistance is rather the extent to which current is restricted to flow through a given circuit. The restriction imposed on the flow of current in a given circuit is measured in terms of resistance. And the resistance, the unit of measurement of resistance, I think we are familiar with that one, is the ohm. Ohms. Resistance is not measured by ohms. So, pese panenge toda measure ma resistance. Tinoenda pa chimwe value of resistance. Which is this one. Sign ohms. Saka uchimeasure resistance, number inobuda apa anenge ari maohms. Well, the same applies kune zvimwe zvese zvakaita se voltage, zvakaita se current, whatever. You have to select the appropriate value per scale. But when testing starter motors, starter motor, electrical tests are mainly concerned with resistance and continuity. Resistance and continuity so for you to test so that meaningful results they are produced, you need to test with the background knowledge design, the construction, knowing the background, knowing the design and construction components, then you test accordingly. So we may start off with something like the housing, design and construction housing. Say, your housing, like we explained the other time, the housing consists of my pole shoes. My pole shoes are retain my thick copper strips. I chose my field coils. My field coils they are retained by the pole shoes. And the internal circuit of your starter motor, we say it is a series parallel arrangement. Current current inopinda the power. This is the terminal nosungirwa kopi solenoid. When the solenoid is attached or mounted above the starter motor, the motor terminal supply current to the field coils. Then the field coils, we've got 2 sets of field coils there. Mamwe 2 outside, mamwe 2 outside. Then to choose a brush, 2 brushes, 2 positive brushes. In the brush, the upper and the upper. So what we expect is there should be an electrical connection between this point and the other brush. this point and the other brush will get up. Okay, let me maybe just illustrate this with a simple sketch of a second. And I'm going to close it. This is the armature and to ground. So this is the motor terminal in the solenoid. So the current flows through the other field coil and through the other field coil. Then the brushes are two. Those are positive brushes. Unfortunately, on this house, my brushes are up and pop. Anyway, one brush up, another brush up. The terminal is in doorway. So when you are testing, you expect terminal E. It is really electrically connected to this point. Terminal E is electrically connected to this point as well. So if you test the continuity at this point and that point, you expect it by the continuity. Current can flow. Don't make yourself busy with the nonsense, please. So I took it in. Can you tell the tester stator motor housing? Tikaisa terminal up. Tikaisa probe meter up. Nipane brush brush they should be. Normally there should be an electrical connection so that there is continuity. We are going to detect continuity. We talk about that's the language that I don't want to use. That took this out of it as we use. I need to go to the in the room brushing. This is normal. Okay, we can test our house. We can show continuity like that. It means that my windings are intact. Okay, then the other point is my windings are insulated. As you can see, my windings are insulated from the housing. My windings are insulated. What we don't want is current which flows into those windings then to ground via a shortcut path without passing through brushes. So it's not tester, it's not insulation, but insulation is not tester till function regulatory continuity. So normally we don't expect to have a continuity between the housing and the windings. So, tikadaiso, nokudaiso. This is what is normal. Those is normal issue. Hakuna current ndofuna kupinda neapa payokudane kuhousing because of ground cannot connect it. But looking at this housing chandina chopana, this thing is damaged. Chakato parallel. So kutu kadaiso that's a problem. You say yes. Kadaiso. This is not normal. Don't go to a tester. It's a pan. There is a possibility that stator motor current will flow through into the housing into ground. Because part of the continuity between the windings and ground. So this is not normal. But obviously, on a damaged component like this one, we expect it. We generally expect to put it because so per housing, there are two important tests that we carry out. To test the continuity of field coils, to test the ground field coils to the housing. As soon as you claim, as soon as you claim, as soon as you see, I should bet your fingertips. Chingo can start motor to what a housing E, whether this large or this small. And the size does not matter, but we always test continuity field coils to test insulation field coils. My field coils should be totally insulated from the housing, and there should be continuous flowing current between my brushes and my brushes and the motor terminal. So there are only two tests that we carry out on a housing. Those are tests that are into continuity as well as insulation. So when it's on to say
and continuity and insulation.
That's very true. Alright. Housing tombo siana tofunga taibati. Then here is the solenoid. Solenoid ready to take function yaro they don't engage a pinion into the flywheel. Function number 1. Function number 2, they connect a battery to the motor, so that the motor is connected directly to the battery. The heavy current can flow. So, can a tester solenoid? And we should also have the functions in mind. Then the construction of the solenoid, it consists of a hollow soft iron core around which a set of windings, we have a set of windings that are wound around a hollow soft iron core, and when a current is supplied from the start switch, into EC start terminal, a magnetic field is going to be created which pulls the plunger, and when the plunger is pulled in, those two functions are then now performed. The engagement of the pinion into the flywheel, the connection of the battery to the motor. So naturally, it's expected that there should be continuity between the start terminal and the motor terminal. No kuti pulling winding head inotangira pa start terminal, then it is grounded via the motor terminal. So if no pulling winding head pa solenoid ese chiterminal ichi chine solder yakabudikira panapa ndo panoperera chi pulling winding head. So between this point and the pulling winding, the termination of pulling winding, there should be continuity. Then between the same point and the housing, here holding winding. Holding winding here inopera per housing. Inopera per housing. It is parallel with the motor. So the two windings, both of them they start at the same point but terminate at two different points. A pulling winding inopera per motor terminal, holding winding inopera per housing. So when testing, we want to confirm that. This is what we confirm. Holding winding yangu yakabatana, pulling winding yangu ichakabatana. We can do that. Can you hold here? Saka meter iri kushanda, ta testa nizoka tuzoona kuti meter iri kushanda. Then when testing the pulling winding, my probes head to my side at the two different ends the pulling winding head, which is at the motor terminal. Motor terminal here up at the start terminal and the motor terminal. So as well as pulling winding head, then ends also at the housing. This is the holding winding. These are holding winding. So I will test the holding winding, I will test the pulling winding. Then we know when the plunger is pulled in, my connected no bridge battery to the what? To the motor. So we expect to put the continuity when the contacts are closed. Then the continuity should be broken when the contacts open. So then you will operate manually. Okay, just leave it. And check out ISO. This is normally the press and pressure barricades to disconnect. This is how it is supposed to work. So you can press your connector, ukaregedza chodisconnect ndomashandira because when pulled in we are connecting the battery to the motor. When the switch is released, the tail spring inobva ichiita pull out, you disconnect the battery from the what? From the motor.
Saka chiri kutoita andafunga kuti chagrounded chitori so.
Can these items get drunk? Vanenge vakarova ine super defined yekubhinga zvinoitwa yekubhinga asi ndodzaunoro ungangoti kuipawo here kuti inoprocesswa sei binga isipwai binga zina vakomana vari kuchihunga mumabhini vakarwaainga first time undopenga zvachusa asi binga quality okay saka pasolenoid tinotesta continuity yefull-in winding, continuity yehold-in winding, then nemacontacts. Totesta nemacontacts. Ndo matest 3 atinotesta pasolenoid.
Same at
pull in, okay. Pull in to is upper. Hold in to the so same upper, the back. That's hold in.
The ground.
The ground. Alright, let's look at the armature. Armature here is innate wire. This is a netting. You can connect to a segment. This we call it a commutator. So, imene wire inobva pasi a specific segment. Yo kuseri kuno dzakafold kwadzobva dzaconnectwa. My wires ese are interconnected. This one is a net. Net wire kuti current flow through one wire, yobudikira through the other one, it connected to the negative. So we expect kuti iri net is really totally insulated from the core, which came to the net, and really totally insulated from the shaft. Shaft ne core is hazvifani kuconducta current irikuita pass through the wires. Then the commutator itself is also insulated from the core and the shaft. If it so happens that the commutator is grounded or the windings are grounded, then power stator motor is really reduced. We have reduced the motor power. Power and motor is really very low. So we have to test. This stator motor is drag. Drag. To test is it not the armature which is grounded? Is it not the windings that are grounded? Then there is also the obvious damage at the corner. This is obvious. You can see this armature is damaged. And an eye inspection. An inspection of the armature would reveal that it is damaged. So obviously you can't expect much out of an armature which is this damaged. Armature is so but outside the inspection name as associated, tinogona kutesta nemeter
When did you